Hello, and welcome back to my YouTube channel. This is just the continuation of the numerical analysis series on my channel. In our last class, we have talked about using the concept of bisection method in finding the roots of an equation, right? And today we are going to be looking at another method entirely, which is called the regular falsi method of finding the root of an equation. We know that under numerical analysis, these two concepts we have actually talked about is they are one of the numerals we have under numerical analysis. We still have Newton-Raphson method, we still have iteration method, and so on and so forth. But today we are going to be using the concept of what regular falsi method. What is regular falsi method telling us? It said that we need two numbers, just like bisection. We need two numbers A. We need two number A and B. A and B. We need two numbers A and B such that A is less than B. Please take note. These are the rules. Such that what A is less than B. And the second rule states that our f of A multiplied by f of B must be less than 0. With these two rules, we are good. We just have to note that our value of A is less than B and our f of A multiplied by f of B is less than 0. Very good. Now, what is this telling us? What is this telling us? It means that we needed a value of A. We need another value of B. How do we get our value of A? How do we get our value of B? We are still going to be using this function. We needed two numbers such that when I input the first one in this function, it must give me a negative number. And when I put the second number in this function, it must give me a positive number. So I needed a negative number and a positive number, right? So let's try. Let's try. Let's say when we have f of 0, what am I going to be having? It means I'll be having 0, in this function, anywhere I see x, I'm going to be putting 0, right? 0 minus e raised to power minus 0. And this will give me what? When we punch this on our calculator, we realize that the answer will be minus 1. Minus 1, right? Very good. So we need another number. We need another number. Let's try f of 1 when x is equals to 1 now. What am I going to be having? It will be what? 1 minus e raised to power minus 1. And this will give me what? This will give me 0.6321. 0.6321. Right? Very good. So let's confirm this number. You can see, we can now say our value of A now, our value of A is equals to what? 0. And our value of B is equals to what? 1, right? We can now confirm that A is less than B. You can see 0 is less than 1, right? So let's confirm the second one. So this is checked. This is checked, right? Let's confirm this now. When we have f of A, what is f of A? Our f of A is what? Minus 1 multiplied by what? Multiplied by 0.6321. You can see it gives me what? Minus 0.6321, which is what? Less than 0. Can you see? So these two values are satisfied our rule. They have satisfied our rule. So what are we going to do? We are just going to plug them in our given formula, right? We are going to plug them in our given formula. Don't forget that we will now be doing for what? X1, right? X1. X1 will be equals to what? A f of B, right? According to the formula, minus B f of A, right? Everything over f of B minus f of A. So how do we input this? Our A is what? Our A is 0. Our f of B is what? F of B is 0.6321. 0.6321, right? Then minus B is what? 1. Can you see? B is 1. And f of A is what? F of A is minus 1. Then we have it all over. This is what? F of B is 0.6321 minus into brackets minus 1. And when we punch this on our calculator, it is going to give us our value of x1. So we can say our value of x1 is what? Our value of x1 will be 0.6127. 0.6127. Right? Very good. Now we have our first iteration, which is x1, and it is what? 0.6127. Very good. Now we need another iteration. You know, when we are talking about numerical analysis, and we are using bisection method, when we are using what's it called? Regular falsi method, interrupting method, we have to iterate as many times as possible until those values we are getting now converge to at least 2 or 3 decimal places. So this is just our first iteration. We need to do our second iterations. So for us to do our second iteration, I usually tell my student that our x1 is not enough. So we need to get the value of f of x1, f of x1, right? So our f of x1, how do we get that? Let me just do it here. How do we get our f of x1? Our f of x1. Now, we are going to input it back in our equation, which is what? X minus e raised to power minus x. You can now see that our f of x1, which is now what? 0.6127, it will now become what? 0.6127 minus e raised to power minus 0.6127. You can see, and this will give us what? What is that going to give us? It will give us 0.0708. 0.0708. What do you now notice? You will now notice that this is giving us a positive value, right? It is giving us a positive value. Don't forget I said something earlier that our f of a multiplied by f of b must be less than 0. Please now listen. Now, take notes now. When we have our a, when we have our b, we need our f of a, right? And we need our what? F of b. Don't forget that for every f of a we have, it must be what? Negative. And, and for every f of b we have, it must be what? Positive. For us to have f of a multiplied by what? F of b to be less than 0. This must be satisfied. Very good. Now, I have my a initially, I have my b initially, right? I have my a initially. My initial a was 0, abi, and my initial b was what? 1, right? When I check for my f of a, it gives me a negative value as expected, and my f of b gives me a positive value as expected. Now, I need to iterate for my second x now. Now, I need my second iteration, and my value of x1 must be included in my second iteration. Our value of f of x1 is also needed in our second iteration, right? And our value of f of x1 is what? We have calculated it, it is what? 0.0708, right? Very good. Now, this is the rule. When we have our iteration and the f of the iteration is positive, please listen. The f of the iteration is positive. It means it is going to be replacing our f of b, right? It is going to be replacing our what? F of b. Then we will use our what? F of a, which is what? Negative. We will continue using that, which means we are just going to be marrying it with what? Our initial a and f of a. But if it is negative, it means it is going to be replacing our what? A and f of a, right? Very good. So I will write out my given data that I have now. So my new a, don't forget, my new a is still what? 0, right? And my f of a still remains what? -1. You will now notice our new b will be what? It will now become x1, right? It will now become x1, which is what? 0.6127. And our f of b, can you see? Will now become what? 0.0708. It's as simple as that. Do you get it now? So you now notice that my f of a is still negative and my f of b is what? Positive. So when we multiply these two together, it will be less than 0. Do we understand? Very good. So let's do for the second iteration. For the second iteration now, we have it to be what? X2, right? Which will be what? A, which is what? 0 now. Into brackets, f of b. My f of b is what? 0.0708, right? Minus, what is my b? My b is 0.6127. Into brackets, what is my f of a? -1. You can see all over f of b, which is what? 0.0708 minus f of a, which is what? -1. And when we punch this on our calculator, our x2 should give us, our x2 should give us 0.5724. 0.5724, right? So we have our x2. Don't forget, our x2 is not enough. We need to get our f of x2. This f of x2 will now tell us the one we are going to be marrying our what x2 with to get our next iteration. So my f of x2 now, when we input it in our equation, f of x2 should be 0.0079. 0.0079. That is my f of x2. Right? You can see it is positive. So we are going to be marrying it with what? The one which the function is what? Negative. Still f of a. Can you see? Very good. So let's get our x3. Let's get our next iteration, which is x3 now. So our x3 now, before I get that, let me write out my gators. So my a will be what? 0. As usual, my f of a will be what? -1. Now my b will be what? My b will be 0.5724. Can you see? And my f of b will be what? 0. Will be equal to 0.0079. Very good. So let's get our value of x3 now. Our value of x3 will be equal to what? A is what? 0 into brackets. F of b is 0.0079. 0.0079 minus, what is b? My b is 0.5724 into brackets. What is my f of a? -1. So everything over f of b. My f of b is 0.0079 minus into brackets. My f of a is -1. And when we punch this on our calculator, my x3 will just be, when we punch this on our calculator, my x3 will be 0.5677. 0.5677. And my x3 is not enough, like I said. I need the value of my f of x3. So when we put that, it is going to be giving us 0.0009. Yeah. So we can use this to find our what? Next iteration, which is x4. We can use that. So now I will ask, which one are we going to be marrying it with? We have our f of x3 to be positive. We need that which what? The f of which is negative, right? We need that of which the f of it is negative. Since our f of x3 is positive, we need f of something that is what? Negative, right? So which will still be what? Our f of a. That is the only one that is negative here. Since our f of b here is what? Positive. Positive multiplied by positive will give us a value greater than 0. Don't forget. So for me to have any value less than 0, I need a negative number and a positive number. You get that? So our next a will still be what? 0 until this one become negative, right? If this one now become, if at this point our f of x3 is negative, it will now become our new a, and the f of x3 will now become our new f of a. But since our f of x3 is what? Positive, the x3 will become what? Our new b, and the f of x3 will become our what? F of b. So it's as simple as that. So a is still equal to 0. F of a is what? Equals to -1. You can see b will become 0.5677, and f of b becomes 0.0009. So we can use these values to get our x4. We can use this value to get our x4. So our x4 becomes a, which is what? 0. F of b is equal to 0.0009, right? Minus b is what? 0.5677 into bracket. F of a is -1. All of this over f of b is what? 0.0009 minus what? F of a, which is what? -1. So when we punch this on our calculator, our x4, when we punch it on our calculator, our x4 will be equal to, it will be equals to 0.5672. 0.5672. Correct. So let's do, you can see the value have become, they are getting closer and closer. You can see My x3 is 0.5677. My x4 is what? 0.5672. It is getting closer, right? It is getting closer. Let's be observant. So let's do the last one. Let's try. Let's find our f of x4. Our f of x4 will be what? Our f of x4 will be input 0.5672 in our given equation. It will be 0.0001, right? So you can see it is still positive. So it is going to be marrying what? Our FA, and our A will become our new A, and X4 will become our new B. X4 will become our new B. So let's write out the given data. Let's write out the given data. So our A is still what? 0. Our F of A is still -1. Our B, will be what? 0.5672. Our F of B will be 0.0001. So we can find our x5 now, our fifth iteration. So which will be what? X5 equals to A, which is what? 0, into brackets f of b. F of b is 0.0001, right? Minus b, which is what? 0.5672, into brackets f of a minus 1. Can you see? Everything over f of b, which is what? 0.0001 minus, into brackets, minus 1. So if we punch this on our calculator, it's going to be giving us x5 will be equal to 0.5671. 0.5671. You can see 0.560. Our x4 is what? 0.5672. Our x5 is what? 0.5671. So since it has actually converged to 3 decimal place, we can take this as our what? Root of the equation. So how do we write it? So we can say the root of the equation lies between root of the equation lies between 0 and 0.5671. I could have said the root of the equation is 0.5671. But when we are using all this method, especially bisection and regular falsi, we are actually getting the approximated root. Please, let's get it clear. We are actually getting our what? We are actually getting our not the actual root. There are some that are closer. When we use them, the values we get will be very, very close to the root of the equation. Take, for example, the likes of Newton-Raphson. Newton-Raphson, when we use Newton-Raphson, any value we get, you will see that before you do about 4 to 5 iteration, your answer will be what? Will be the same, which tells us that that value you have gotten is the actual root of the equation. I guess what I'm saying. But this one we have got here is what? Is the approximated root. So we can now say the root of the equation lies between 0 and 0.5671. I hope that is clear. So thank you very much for today's class. I'm very happy we have actually learned a lot from this class. So till we meet again. Bye.